Algebra. We are getting PO62 today, which is kind of the Bowser of equations, shall we say. It's got the most stuff going on, and we call it variables on both sides. Okay? So you can look down at some of the examples. Example of variables on both sides would be like 18x equals 14x plus 20. Negative 10n plus 18 equals 8n, 9y minus 8 equals 4y plus 42, etc. Right? You've got whatever variable that you're solving for, you've got some on both sides of the equation. Okay? Now, when we think about solving an equation, our goal is to always isolate the variable. And we typically do that using opposite operations, moving everything away from the variable, right? So when you have variables on both sides, basically the only extra step here is getting all of your variable on the same side of the equation, okay? And how do you suppose we would do that? How do you suppose we would move a variable term from one side of the equal sign to the other? What would our process be? Enough of that. Yeah?
You subtract it from both sides.
Well, it kind of depends. It kind of depends. Sometimes you subtract, sometimes you would add, okay?
Yeah.
And the process that we're using is the same process we seem to always use when solving an equation. Tony?
Opposite.
Excellent. Okay. So the goal of variables on both sides is to put, well, I gotta calibrate, to put all your variables on the same side of the equation using opposite operations.
Beautiful.
Yes. To put all variables, there we go. All variables on the same side of the equation using opposite operations. Okay, to put all variables on the same side of the equation using opposite operations. Again, to put all variables on the same side of the equation using opposite operations. Warning for you. Okay. So the example we talk about 18x equals 14x plus 20. It doesn't matter technically which side of the equal sign our variables go on, but since 18x is by itself over on the left side, and the 14x has that constant 20 with it, which makes more sense here? To move our 14x's over away from the 20 with the 18x's, or put everything on one side, the variable term and the constant? What do you think? Huh?
Different sides.
Different sides, right? If our goal is to eventually isolate x, then if we can start moving stuff away from our constant, get everything on one side, opposite of our constant, that's the way to go. Okay? So we're going to move our 14x's over to the left. Griffin, do you have your binder? Yep. And we said our method is opposite operations. So in this case, since it's a positive 14x on that right side, how are we going to move it over? How are we going to move it over? We want to move all 14x's. We're not splitting apart the 14 and the x. We're moving them all over. Haley? Subtraction. Okay? Subtraction. Normally, when we deal with a coefficient in a variable, it's with multiplication or division. But remember, when we do that, it's because we want to separate the coefficient from the variable, right? We want to get down to one of whatever x is or y or whatever. Here, we're taking all 14 x's and moving them over to the left side. We have 18, we subtract 14. That leaves us with 4 of them. On the right side, they're now gone, right? We moved them, so they aren't there anymore. 4x equals 20. Now we want to get x by itself. And so here's where we would then, again, opposite operations, divide both sides by 4 to get it down to 1x, and x equals 5. There you go. Okay? You've got variables on both sides. Great. Move them all to one side. And that'll either give you a 2-step or a 1-step equation from there. Let's look at the next one. Negative 10n plus 18 equals 8n. If it makes more sense to move my n's over to the right side, away from that constant, since that's what I'm going to be doing anyway. In this example, how am I going to do that? Move my group of negative 10 n's over to the right. Sophie?
Add 10 to both sides.
Add 10 n to both sides. Yeah, good. Okay. Negative 10n plus 10n, they cancel out. We moved them, they're not there anymore. That's the whole point. And so we get 18 equals 18 n's. 8n plus 10n. Divide both sides by 18 to get n by itself. And we get a value of 1. And a value of 1. Initial questions. Questions so far. Good? Okay. Anything jumps? Yes, Kate.
Can I do my calculator?
What's that?
Is your brother? And can I go get my calculator, please?
Sure.
Thank you.
Now, in this third example, it doesn't really matter which side we move all of our y's to, because both sides have a constant with it anyway. You know, so it's not like one makes more sense than the other. So you have options. All right, Colin, would you like to move our 9y's over to the right side or our 4y's over to the left side? The good news is there's no wrong answer. I just need someone to tell me what I should do. Move the 9y's. Okay, so how are we going to move our 9y's over to the right? Using opposite operations, what are we going to do here? Johnny?
Subtract.
Subtract. Okay, subtract 9y's from both sides. And that leaves us with negative 8. 4y minus 9y is a negative 5y. And then we have that plus 42 over here. So do pay attention to signs. Okay, it's going to be 4 minus 9. And that gives us negative 5. Your calculator's in your pouch the whole time.
Sorry, I didn't know that.
That's crazy. Now what are we going to do? We have a two-step equation. Tony?
Oh, let's start the constant.
Yes. Good.
Add 8.
So this constant already by itself, we want to move everything away from the y variable. If we add 8 to both sides, we're just moving this negative 8 over to be on the same side as y, which at this point, being a two-step equation, that's the opposite of what we want, right? We want to get y by itself. So instead of adding 8, you see what we should do? Subtract what? What's the constant?
42.
Subtract 42, right? Subtract 42. Okay. Negative 8 minus 42 is a negative 50. That equals negative 5y. And then our final step would be to divide by negative 5. Okay. And negative 50 divided by negative 5 is a positive 10. Positive 10. All right? Now, Colin made the decision for us to move our 9y's over to the right. Let's go back in time. And this time, Colin, why don't you tell us to move our 4y's to the left? Colin, what would you rather do? Would you rather move our 9y's over to the right or our 4y's over to the left? The good news is there's no wrong answer. I just need someone to tell me what I should do.
4y to the left.
Very good. Okay?
You guys write this.
You don't have to write this down. I'm just showing you that it works out. So subtracting 4y from both sides, this time moving our y's over to the left side. So they cancel out on the right. 9y minus 4y, this time is a positive 5y instead of negative. But that's okay because the 5y is on the other side of the equation, right? Having a positive 5y on the left is kind of the same thing as having negative 5y on the right. Because now, right, Tony was just answering a question from the future earlier. We would add 8 to both sides. Because now our y's being on the left side, we want to move everything away from them. So adding 8 to both sides gives us 5y equals positive 50. Notice how our 5y is positive on the left and our 50 is positive on the right side because their sides switched, doing this other method. Divide both sides by positive 5 and we still get a value of positive 10.
No, it
Okay.
doesn't.
So it does not matter which side you move your variable to. Once you do it, it's just opposite operations from there.
That's
Okay.
crazy.
What's that?
That's crazy.
It is.
That's
It
kind of
is.
crazy.
Called math.
Indeed.
Wait, so are we in the present now? Or are we?
We are in the present.
the
Soon we'll be in the future. Oh, now it's the present. And now it's the past.
Yeah, it was a
Crazy how
past.
time flies. The last one here. Someone give me a first step. What do you want to do? Sophie. Bless you. Okay. So Sophie wants to move the negative 4n term over to the right. And how are you going to do that, Sophie? Add 4n. Okay. So plus 4n, plus 4n. Make sure you're adding the 4n to the correct term on the right side. It's got to be added to the 8n term because they both have n's. Let me help you out here. Let me remove this. Let's see. You have no notes
I lost.
taken. And so, all right. So add 4n to both sides here. That gives us negative 3 equals 12n plus 21. We have a two-step equation, so now we want to start with our constant, move it to the other side. Second step, multiply and divide. Jeffrey, what would we tell me what to do.
Subtract
Subtract what?
12.
No.
Start with the constant.
Constantly start with the
21.
constants.
Subtract 21. Right?
21.
Subtract 21. Okay. That variable term gets dealt with last. Once we're in our two-step equation safety mode here, that variable term gets dealt with last. So negative 3 minus 21 is a negative 24, and that equals 12n. Divide both sides by 12 to get n by itself now, and we get an n value of negative 2. An n value of negative 2.
That's low.
Okay. If opposite operations, another way to think about this, something like that, is my little avatar here, which means there's a nifty tidbit to be had. Okay. You can kind of relate variables on both sides to a basketball score. You know, if you are ahead 17 to 14, that's really the same as being ahead 3 to 0, right? It's like you don't get style points or bonus points for scoring. It's like you just want to score more points than the other team. Whether you win 17, 14, or 3-0, it's the same either way. Okay? So if you look at an equation and you see that one side's got 17 x's and the other side's got 14 x's, using opposite operations, we might choose to subtract 14x from both sides, right? And 17x minus 14x would be 3x. Or you can just kind of think about it, well, how many more x's does the left side have? Left side's got 17, right side's got 14. How many more x's does the left side have? 3. And that's what we would end up with anyway if we subtract 14x from both sides, right? So if you look at this, and in this first example here, we had 18x equals 14x plus 20. How many more x's did the left side have? 4. And that's what we got when we used opposite operations. The second one, negative 10n and 8n. This is tricky because that negative sign, but think of negative 10 and positive 8. How many more n's were on the right side? 18. Think of negative 10 to positive 8. That's a difference of 18, right? And that's what we got here. The third one, 9y and 4y. How many more y's are on the left side? 5. And that's what we got here, right? And then this one, negative 4 and positive 8. What's the difference between negative 4 and positive 8? How far apart are they on the number line? Negative 4, positive 8. How far apart are they on the number line? 12. And that's how many n's we had when we used opposite operations.
1,200.
Okay? So you can kind of, opposite operations works. But you can also kind of look at it and logically think, well, if I've got 3 more on one side than the other side, that's how many X's or N's or whatever will be left over. Jay. Okay. All right. A couple for us to practice as a group, but I'm going to let you take the lead. Oh, there are more right here. Let's have you work through the first 2. I will pause the video and we'll come back. Yes, Tony.
Can those little avatar things go on the help sheet?
The nifty tidbits? Sure. Nifty tidbits can go on the help sheet. All right. We'll pause. We'll come back shortly.
Bye.
Griffin, Johnny, Camille, Kate, warnings for all of you. I counted down. You should be facing the front. Griffin, why don't you get us started? What do we do first here?
So
Quit and sit flat, please. Thank you.
5x is bigger than 2 by 3.
Yes.
3x.
Very good. Okay, so we have 3 more x's on the right side, right? 2 on the left, 5 on the right. There are 3 more on the right. If you use opposite operations to subtract 2 x's from both sides, you'll find that you have those 3 x's that Griffin was referring to on the right side and no more on the left. Your other option would be to subtract 5x from both sides, move everything over to the left side, in which case your initial equation here would read negative 3x plus 1 equals negative 14. As long as after your first step you've got one of these 2 things, you are in good shape. Okay? Depending on whether or not you move your x's to the right or to the left, it's going to look like one of those things. You will get the same answer either way. Does not make a difference. Shay, question.
Can we do this second to last one when you're done with this?
If there's time, we shall see. So then you would add 14 to both sides. 15 equals 3x. Jeffrey, second warning for you. Liam, you're first. Okay?
For what?
For distracting the class.
For how am I distracted class?
I stopped with
Evan.
That was Ethan. Mr. Schultz, that was Evan.
Second warning for you. I would tread carefully.
That
You've
was
got 3 minutes left.
Bruh.
Tony, warning for you as well. You got 3 minutes left. Let's
I wonder how that it sounded on the microphone.
well, you have to watch. Then divide both sides by 3, and you've got 5 equals x. If you did it the other way, you move that 1 over, and you have negative 3x equals negative 15. Divide both sides by negative 3, and you still get x equals 5 as a final answer. Okay? So either way that you started, x ends up being positive 5. Next one. Jeffrey, start us out.
Okay. So I would subtract both by negative 15.
Okay, so subtract by 15. Jeffrey's moving his variables over to the left side, which is fine. You end up with negative 3n minus 3 equals negative 21. If you moved all your variables over to the right side, your second step looks like negative 3 equals positive 12n minus 21. You will get the same answer either way. Okay, as long as you have one of these 3n.
That's what I thought.
As long as you have one of these 2 equations here, it works out to be the same. Okay? And what do you get when you finish solving this and your value for n? Kate?
And it equals 6.
N equals
I did
6.
not get that. Messed up.
Okay? Jack, I need you to count real quick.
Sorry, I just can't count.
They're crazy.
It's okay to get off on tangents if, when it's time to get back on the main path, you're able to do that. Okay, today did not go so well getting back on to the main path. Okay, so we need to work on that, get a little bit better. Johnny.
What's the homework?
Your homework will be these next 2. For this one, I'm going to give you a reminder. The coefficient to that n on the right side is a 1. There is 1 n there. So that may help clarify things a little bit. Okay?
How do I move it to 2?
What's that?
I move it.
Kate, second warning for you. What was that, Shay?
The 4 is in front of it. Does it affect it at all?
Nope,
Okay.
it does not. It does not. Griffin, second warning for you. Okay? We got like a minute left. Let's just reel it in. If it means put your head down on your desk and, just, so that's what it means. Okay? Jeffrey.
What's a tangent?
Tangent is like the scenic route. It's an off-topic conversation. Silly moments. Yeah. All right, your homework is the last two in that section. That's
Okay, the last
math.
one.
Don't forget,
Like,